Okay, welcome everybody. This is my first time recording something on this Mimeo thing, so I hope it works out. You won't ever be able to see me. You'll just hear my voice, hopefully, if all goes well, and you'll be able to see everything that I write on the board. So it's really helpful if you have your notes with you. The notes is something that I will eventually, hopefully, be able to put on Blackboard where you can print it out and then just follow along and copy everything and kind of learn everything. And the good thing about a video is you can watch it at 3 o'clock in the morning and you can play it back to your heart's content, and it really works out very well. So let's go through this. What we're going to do is, back in the day, if I asked you to find the square root of 50, you would have pulled out a calculator and given me an answer. And what you would have probably given me, if you have a calculator, is approximately 7.07. And that's what that is. It's approximately 7.07. But that was more like a 6th and 7th grade issue. You just want to find what was called an approximate answer. So we have a little squiggly. But in algebra, we're going to find something in what we call radical form. That's going to be the exact answer. So I'm going to take the same problem. I'm going to take the square root of 50, and I'm going to use all my perfect squares. And here they are: 1, 4, 9, 16, okay, 25, and 36. And I'll just put a few more: 49, and of course this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5, 6, 7. And I can stop there for now. All right. The property says if I take a radical AB, I can break it down into radical A times radical B. Now, what does that mean? I can take the number 50, just the number 50, and I can write it as 2 factors of 50, but one of them needs to be a perfect square. So what we're going to do is we're going to take the number that's inside the radical, let's call the radicand, and we're going to find the highest perfect square factor of 50. And of course, that's 25. So I'm going to rewrite 50 as radical 25, and radical means square root. Radical 25 and radical 2. Now, radical 25 is 5. So this answer is going to become 5 radical 2. So the square root of 50 is actually 5 times the square root of 2. That's the exact answer. Now, if you do that on your calculator, you're going to get 7.07. But that's what we want. We don't want 7.07 anymore. In fact, I'm just going to erase that. This is what we want. We want 5 times the square root of 2. Okay, same idea for the next couple of these. We'll take the square root of 48. Now find the largest perfect square factor of 48, which is 16. And we're going to go 16, and we're going to go 3. 16 times 3 is 48. Now, that's going to become 4. That's 4. 4, square root of 16 is 4, times radical 3. Radical 3 isn't a perfect square, so we're just going to write it as 4 radical 3. And for this, we always want the number first, followed by the square root. Okay, square root of 20. 10 times 2, but none of those are perfect squares. We can go 4 and 5, right? 4 times 5. So radical 4. I always put the perfect square first. Radical 4 times radical 5. Now radical 4 becomes 2. So that becomes 2 radical 5. Now the good thing about this can actually be checked on the calculator. You can actually take this and get a decimal, and then multiply this times this and still get the same decimal. So you can actually check this on the calculator very well. Okay, 44 is going to be 4 and 11. So we're going to write this as radical 4 times radical 11. And that's going to become 2 radical 11. By the way, my writing is a little sloppy because I'm writing with the mouse, actually, instead of with my left hand. Okay, so that's our first part of the game right here. And that's some of our basic square roots. Okay, moving on. We'll take 160. 160 is going to be 16 and 10. And you'll have a perfect square chart, which I'll give you in class to help you with this. And it's also going to be on the board the whole time. So 16 radical 10, which is going to become 4. Square root of 16 is 4. 4 radical 10. Okay. And we're going to practice a lot more of these, trust me. All right, but there's going to be some twists and turns like there always are in algebra. Okay, we're going to also throw in some variables. You're going to see variables here. Let's do the number first. So radical 54, we want to simplify that. And then we want radical n to the 7th. What you do when you have an exponent, an odd exponent, is you subtract 1, and we're going to write it as n to the 6th. And that's going to leave 1 left over, so we're going to write that right there. Remember, n to the 6th times n is n to the 7th. All right, we're going to take 54 and write it as radical 9 and radical 6. 9 times 6 is 54. But 9 is the largest perfect square factor. So we have a 3 This 9, radical 9 becomes a 3. Any even exponent we can find the square root of an even exponent by cutting it in half. So half of 6 is 3, so that becomes n to the power of 3. And that's this one. What we have left over is a 6 and an n. Those are not perfect squares, so we're going to put them on the inside the house, so to speak. And there's our answer. It's a little confusing, but you're going to get it. Over time, I promise you're going to get all these, and you're going to be fine. Okay, let me erase this. You'll just have to play it back if you need to see it again. That's the good thing about a video. All right, radical 80 is actually, if you use your chart, it's going to be 16 and 5. 16 and 5. x9, now don't confuse it. We're not taking the square root of 9. We're just going to subtract 1, and that's going to be x8. And I believe there's going to be 1 left over right here. So let's pull out everything that's perfect. That's 4. So 4 is on the outside. Anything that's perfect square is outside. x8, cut it in half. So x to the 4th. And the two things that are not perfect are 5 and x. So they're going to go right here. 5 here and x here. Okay, next one. Radical 300 x to the 8th. Oh boy. All right, we're going to write this now. 300 becomes 100 times 3. Remember, 100 is a perfect square. 100 and radical 3. It doesn't matter where you write these. I just write them all over the place. x8, x8 is an even power. So we're just going to write x to the 8th. No need to break it down. It's already even. Now, ask yourself, what's perfect? That's perfect. That 100 is 10. Any even exponent is perfect. Just cut it in half. That's x to the 4th. And then what do you have left over is radical 3. And there's your answer. Now, unfortunately, with variables, you're not really able to check these on the calculator because we don't know what the value of x is. You're just going to have to take it for what it is right there. Okay, sometimes you're going to be asked to break things down. You're going to be asked to kind of take radicals that are already broken down, and actually put them back together. You have to actually take these two, multiply them together, and then break them apart again. I'll explain. So here it is. Let's do this. Take this whole thing times this whole thing. Yuck. Okay, what we're going to do is going to take 2 times 3 first. Take the outer numbers, multiply those. That's 6. Now, we're going to take a radical times a radical. You can do that. So you take 14 times 3, and you're going to get 42. 14 times 3 is 42, I believe. Yep. And then x times x squared is x cubed. By the way, pretty much all these problems are from the textbook at some point. Okay, if the 6 is on the outside, that's fine. We'll leave that alone. In fact, I just put a little box around it. We're going to come back and use u later. We're going to break u apart. 42 can actually be 3 and 14. There's 7 and 6. There's 21 and 2. I don't believe there's anything else. So we're just going to write 42. We're just going to write 42. We can't break radical 42 down anymore. But we can take x cubed and break it down into x squared. Remember, subtract 1. It's an odd number, so subtract 1. X squared and x. So our answer is going to be 6. 6 is fine. X, that becomes an x. That stays on the outside. And on the inside, we have 42. That's not perfect. 42, and then an x. And there's our answer. I know, these are a little weird, a little tricky, but if you play with it, you'll get it. I promise you will. All right, a couple more. All right, that doesn't matter which one we do next. Let's just do this one. We're going to do 3 radical 6 times radical 18, so we can go 3. Remember, that's a 1 right there, 3 times 1. And then 6 times 18. 6 times 18, I believe, is $1.08. I believe. I hope I'm writing that right. Yes, 108. Okay, now 108 is actually 36 and 3. So what we're doing is we're rewriting this and breaking it down the right way. 36 is the largest perfect square factor of 108. See, 36 times 3 is 108. Okay, these are factors of 108, but they're not perfect square factors. So we're going to that's the purpose of this. We're going to build it back together and break it apart the right way. So this is going to become this is already a 3. Leave that alone. That stays the same. That's a 6. So 3 times. Remember, we're multiplying. 3 times 6. We can't do anything with that. So radical 3. So 3 times 6 is 18. So we're going to have 18 times radical 3. And there's your answer. That's it. Okay, and by the way, this does not have variables, so you could actually check this on the calculator. You could actually multiply this out, get decimals, and see if it works the same way. It should. Okay, this one here. Okay, we can multiply radical times a radical. 2 times 9 is 18. A times a cubed is a to the 4th. Okay, so we're going to break this down the right way into 9 and 2 and a to the 4th. Okay, square root of 9 is 3. Square root of 9 is 3. Square root of a to the 4th is a squared. And then what we have left over is radical 2. Sorry, I can't write my radical signs too well. And then there's your answer. These do get kind of messy, so you're going to have to just show your work. Please show your work, and then circle your answer, especially if it's a quiz. Okay, last one for now. Take the numbers outside. If there's numbers outside, just multiply them. 7 times 3 is 21. Okay, now multiply the radical times radical. So you got 5 times 20, which is 100. You can probably see where we're going with this here. Okay, that's going to become a 10, right? And then x times x to the 5th is x to the 6th. Remember, you add the exponents here. So you got 21 sitting on the outside. Leave him be for now. Square root of 100 is 10. Okay, we have the square root of 100. Getting a little ahead of myself here. And then x to the 6th. See, I'm just breaking everything apart. This is the whole idea. Breaking it apart and putting it back together the right way. So 21, that's the 21, times 10, that's 10. So that's going to be 210, right? 21 times 10, 210. And then we're going to have on the inside the radical. Oh, I'm sorry, wait, there is no radical here because that's sorry, my fault. So we're going to have 210. Be patient with me here. This is my first video. X to the 6 is even, so that just becomes x cubed. So there you go, 210 x cubed. There are no radicals at the end here. That's it, 210 x cubed. Okay, moving on. What if we have fractions? Oh, we don't like fractions. Okay, the basic property is this. We can take a fraction. This is from the textbook. Radical a divided by b becomes radical a divided by radical b. So radical 64, these are kind of quick. Radical 64 over radical 49 becomes radical 64 over radical 49. Now, radical 64 is 8. Radical 49 is 7. Leave it like that, 8 over 7. I don't want decimals. I don't want mixed fractions, 8 over 7. Okay, radical 144 over 9 becomes radical 144 over radical 9, which becomes 12 over 3, which is 4. By the way, you can also divide this inside. 144 divided by 9 is 16. The square root of 16 is 4. So you get that answer that way too. Okay. Let me give you some space here for this. When I do these videos, I go at a pretty good pace here because you can always pause it and rewind it. So if I'm going too fast, just play it again, play it again, play it again. All right, I'm going to write this now as 8. I know you're laughing at me. 8x cubed over radical 8x cubed over radical 50. Okay, there's a lot going on with this one here, so stay with me. Okay. We're going to keep this going here. We're going to simplify this. Radical 8 is going to become radical 4 and radical 2. These are actually kind of fun. Believe it or not, they really are. X cubed becomes radical x squared. Remember, subtract 1. And then radical x. There's 1 left over. Remember, x squared times x is x cubed. All that's on top. On the bottom, we got 50. Now, 50 becomes 25 and 2. We've done some of these before. 25 and 2. 25 and 2. And then x. X is by itself. Now, you learned a long time ago, anything on the top in the numerator can cancel with anything in the denominator. I don't care what it is. It could be a pencil over a pencil. It's gone. So radical 2 over radical 2 is gone. Radical x over radical x is gone. So what you're going to have here is on the top, you can have 2x. This is x right here. 2x over 5. That's it. 2x over 5. All right, one more. This is a lengthy video, so you're going to have to just stay with me. But again, if it's time for bed or whatever, just pause it and replay it tomorrow. Okay, so what you got? Technology is great. So I'm going to break this down as radical 36. I'm not going to skip any steps here. Radical 36 over a. See, what I'm doing is I'm taking the big radical, that's a big radical, and dividing it into two baby radicals. Okay, now what's that going to become? Radical 36 becomes, radical 36a becomes radical 36 and radical a. I hope you show all the steps when you do this on a quiz. Remember, there's no test in this unit. It's just going to be one big quiz. Okay, radical 4 right, and then radical a squared, and then a radical a. And like I said, these are kind of fun. These are kind of cool. So what you're going to have, these are gone, right? A over a is gone. So what you're going to have on the top is 6. Radical 36 became 6. Radical 4 becomes 2. And radical a squared becomes a. Now, you can divide anything by anything. They don't have to be like terms. 6 divided by 2 is 3. So you're going to have 3 over a as your answer. Remember, 6 over 2 becomes 3. And there you have it. Okay. Moving on. Okay. What I'm about to do here is more of an honors type thing. So if you are in regular algebra, go ahead and skip this. This is not the end of the video. Go ahead and skip this. You're certainly welcome to watch it, but I don't think I'm going to put this on a regular algebra test. This is more of an extension. What you're going to do here is what's called rationalize the denominator. Here's the problem. I'm going to take radical 3 over radical 7, and I'm going to break it down into this. Everything we've done before, the bottom was always a perfect square. But radical 7 is not a perfect square. So what I'm going to do is I'm going to rationalize this, and I'm going to multiply the top and bottom by whatever's on the bottom. It's called rationalizing the denominator. I'm going to literally whatever's on the bottom gets multiplied, the top and bottom. So what we're going to have here is multiply this together. You can get radical 21 over radical 7 times 7 is 49. Radical 49. Okay, what you're going to have now is radical 21. That's going to become radical 21 over 7. Okay, you can have a radical on the top. You can't have one on the bottom. And you can't take a number and divide it into a radical. You can divide a radical by a radical. You can't take 7 does not go in the 21, radical 21. Okay, so you have to leave it just like that. Just like that. Let me say that again. You cannot divide a number into a radical. If this was radical 7, then you could divide it by and get radical 3. But you cannot divide a number into a radical. Okay, let me give you some room here. Radical 2 over radical 3. So we have radical 2 over radical 3. Okay, you got to get rid of the radical 3 on the bottom. That's the rule. So you're going to multiply the top and bottom by literally whatever is there, radical 3. So what are you going to have here? This 2 times 3 is 6, so radical 6 divided by 3 times 3 is 9, radical 9. Now also, don't go reducing these, okay? This isn't like reducing 6 over 9. So you have radical 6 over 3. That's 3. Radical 9 is 3. And you're done. And once again, you cannot divide that. You're done. See, there's no radical in the denominator. That's our goal here. No radical in the denominator. Okay, stay with me on this. And if you're on regular algebra, just fast forward a little bit until you get to the next page, which is right here. Okay, we're going to get there in a minute. Okay, honors people, stay with me. Stay with me. Unless you, of course, you already know this. Okay, take radical 5. This is this problem here. Radical 5 over radical 18 m. Okay, I'm going to multiply both sides, top and bottom, by radical 18m. Okay, so this is going to become 5 times 18 is 90. So you can have radical 90 m over 18m. Okay, I don't know if you notice this by now. If you take this and this, anytime you take anything times itself, all you have to do is pull out what's underneath. It's 18m. Now, 90 can be reduced again. Radical 90 can be radical 9. Now, I told you guys this is a tricky section of this unit. 9 times 10 is 90, and of course we have an m left over. Okay, so this is going to become, this is all on the top, 3. This becomes a 3. And then we're going to have inside the radical 10m over 18m. And just when you think you're done, you're not. 3 over 18 becomes 1 over 9. So you have 1, and you don't need to write the 1. So 1 over 10m over 9m. Don't cancel the m's. One's inside the radical, one's not. There's your answer. Okay. Oh, hang on. Got ahead of myself here. Okay, these are a little bit quicker. Okay, this could become radical 7s over radical 3. Got to get rid of that radical 3, so we're going to multiply the top and bottom by radical 3. Literally, whatever's in the denominator is what you're going to multiply. So, you're going to multiply these together. You can multiply anything by anything, so you can get 21s. And that cannot be broken down anymore, so we're done. Radical 3 times radical 3 is radical 9, which just becomes 3. And we're done. You cannot divide a number into a radical. We are done. We are done. Okay. It's funny, I'm so used to stopping and asking for questions and all that, but when you do a video, you really don't. Because you can just, the kids can just play it again and again. Okay, I'm going to take radical 6 and break it down into radical 6 and radical 13x. This is going to take a little bit of time in class to do. Okay, so top and bottom. I haven't done this yet. I'm recording this video before I teach it. I want this up and ready on Blackboard. Okay, so what we're going to have now, this times this is 78, radical 78. I don't believe that can be reduced. So radical 78x all over 13x. And that's it, folks. That's it. And even though this goes in the 78 6 times, you cannot do it. You cannot touch it. We're done. Okay, folks, that's called rationalizing the denominator, and that's really for the honors folks. Okay, this is for everybody now, so I hope we're all kind of doing this now. This is kind of like the end. This is just a miscellaneous piece of paper that I have. It's just these last 3 pages here. And these go kind of fast here, so let's do it. Okay, the 8's on the outside. I'm going to write the 8 as 8 over 1, because I have a fraction, times, this is always times, radical 13 over radical 9. Yeah, broken down the right way. Okay, you can multiply anything times anything. So 8 times radical 13 is just 8 radical 13. 1 times square root of 9. Square root of 9 is 3. 1 times 3 is 3. And leave it like that. Just leave it like that. Leave it like that. I don't want decimals. I don't want mixed fractions. Leave it be. Leave it be. By the way, I forgot to tell you, this page is kind of some special types. Okay, there's always special types in algebra. So this has kind of got some of the curveballs and sharp turns and kind of thing. Okay, you are allowed to divide a radical by a radical. So I can actually take this divided by this and get radical 4, which becomes 2. Now, if I didn't know that, I could just take 6 divided by 3 and get the same answer. Don't you just love algebra? Don't you just love it? All right, radical 48 becomes radical 16 and 3. Remember, it's not 8 and 6. 16 and 3. And by the way, it's also not 12 and 4. A lot of people think it's 12 and 4, but 12 can be broken down again. So we're going to use 16 and 3. And radical 81 is just 9. Now, radical 16 is 4. So 4 radical 3 over 9. That's it. Okay. Nice, nice, nice. Couple more, couple more, couple more. All right, 1/2. We'll throw the 1/2 off to the side. We'll use you later. 32 times 2. You remember, you can multiply anything times anything. 32 times 2 is 64. Just keep up. Make sure it's a radical. Radical 32 times radical 32 times radical 2 is radical 64. Try saying that fast a couple times. All right, so 1/2 times is always times 8. That's 8. 1/2 times 8, which is 4, 4, 4, 4, 4, 4. Okay, sometimes you're going to be left with just these kinds of things. Again, these are just from the textbook. So we're going to write this as radical 100. In class, these might be the ones I'll just have you try. But I'll just do it on video. That becomes 10. Radical x, leave it alone. Radical x, there it is. Anytime you don't see a sign in between these are all implied multiplication. This is all implied, this multiplication. All right, radical 49 x squared. I think we believe this was an SOL question from some time ago. So radical 49 and radical x squared. This one's nice and even. That becomes 7, and that becomes x. Half of 2 is 1, so 7x. No radicals here, just 7x. Okay, finishing this off here. Last 2 pages here. This is these are good ones here. These are the SOL type questions. These in my opinion, these are the fun ones. There's no fractions. It's just break it down. You'll like this. I promise you will. Okay, radical 81. I know. I'm excited. Radical 81 becomes 81. They're all laughing at me. And then the square root of x to the 8th. Remember, it's even, so just pull it out. That's going to become 9, and then that becomes half of 8 is 4, so 9x to the 4. Let me do that. Let me just do this column. We'll come back and do this column. Save a little time. All right, radical 64 is radical 64. Okay, x to the 9th, subtract 1, so x8. Anytime it's odd, you subtract 1, and you got 1 left over. It's always going to be the case when you have an odd exponent. Okay, that's going to become 8. If it's excuse me, if it's even, cut it in half. X to the 4. And then, of course, we have an x at the end, and we're done. And we're done, and we're done, and we're done. All right, I can fit this in. 200 is going to become radical 100. And radical 2, right? 100 times 2 is 200. And then x to the 8th. I don't know why I kept throwing x to the 8th in. Okay, so that's going to become 10. That's 10. I even, sometimes in class, I'll cross them off as I go. Pull out the even ones first. That's 10. Skip that one. That's 4. Half of 8 is 4. So 10x to the 4th. These are outside playing. I think last year I used it was spring, so it was nice outside. These are kind of outside playing baseball, and this is the one that's stuck in the house because he's not a perfect square. So there you have it right there. All right, if you're still kind of hazy on these, we got a couple more practice ones. I think you're going to be fine. When all is said and done, you're always going to be fine. You're always going to be fine. Okay, radical 64 is radical 64. Pull out the number first. A, there's only an A, so pull out radical A. Remember, that's odd, so that's not perfect. B to the 4, that's even, so we like U. So that's 8. That's 8, right? 8. Skip U. That's B squared. Cut it in half. B squared. And then the one that's stuck inside is the odd estimate. Remember, that's a 1 stuck inside. We can't do anything with U. And we're done. Okay, 121. Let me just write it over here. 121. I believe that's going to be 11. X to the 5. Okay, so pull out 4 of them. Pull out 4. There's 1 left over. Y to the 8th is even. If it's even, we love it. Pull it out. Yank it out. It's perfect. Okay, now, this is 11. This is 11. That's x2, x squared. And by the way, we do this alphabetical order. That's y to the 4th. And the one that's stuck inside the house is an x. Think of the radical thing like a little house. And there's your answer. Boop. Okay, 128. You gotta look at your chart. Is 64 and 2. 64 is the largest perfect square factor. And then x7, no, we don't like the odd ones. We have to pull out the highest even, and then one left over. Okay, so that's 8. Skip u. That's x3. Half of 6 is 3. x3. And then the two that are stuck in the house, and if they're together, just write it next to each other. It's 2 and an x. We're done. We're done, we're done, we're done. All right, give me a second to erase this. And you can rewind it and play this to your heart's content. Let me show you one more. Last 4, I promise you. Last 4. All right, these are a little tougher. These are the ones where if you can do these, you understand it. These are the main. In fact, this one right here, this last one, this was on the SOL 2 years ago. This exact same problem. And I believe this was on last year's, if I'm not mistaken. Okay, these are a little challenge. I think we can do it. All right, 300 is going to be 100. Excuse me. Take a sip of water. 100 times 3, that's 300. X cubed is x squared, and x. Y7, sometimes there's a lot of these, is y6, and there's one y left over. Now, who's playing outside? This guy's playing outside. There's your 10. Skip that. That's an x. Skip you. That's a y3, y cubed. And then what we have left over is everything that's inside. 3xy. You're stuck inside. Maybe you didn't do your homework and you're grounded and you have to stay inside. Okay. That's that one. I gotta erase. There's a lot of writing here, a lot going on here. Okay, the 245. That one has 245. How did we do that last time? Let me think about that for a second. Let me look at my square root chart. I'm actually looking at the board right now. Trying to remember which one that was. 245. Okay, I'm going to need a second. Actually, I'll come back and do this one. 80 is become 16 and 5. It's funny, sometimes you just remember these from year to year. Can't quite remember what 245 is. I know it works. Okay, x11 is x10. There's one x left over. So this is going to become 4. We like you. X to the 5th, right? Half of it. I'll prove that to you in class why that works. And then what's left over is in the house, 5x. What is that 245? Give me a second here. I am playing with this on my calculator. I don't... 245... 245 divided by 64? No. 245 divided by 36? No. 245 divided by 16. No. 245 divided by 64. Okay. Maybe I will hold off on that one. Okay, let's do this one. I like this one. This was on last year's test, or 2 years ago. 180 is actually 36 and 5. 36 and 5. X9 is X8. And there's one X left over. I remember this problem. And Y16. Ah, this is where they tried to trick you on the SOL. They made 16 a perfect square. It's not. We're just going to cut it in half. A lot of kids are going to put Y to the 4th here. Be careful with that one. Okay, so this is 6. Skip you. That's X to the 4th. That's Y to the 8th. And then who's inside is radical 5x. And there's your answer. Okay, I'm going to quickly look at this 245 here for a second. Just give me a second. 245 divided by 4. No. 245 divided by 9. Nope. You know, maybe this doesn't work. 96. Nope. Okay, I'm sorry. It's 49 and 5. I'm so sorry, everybody. I'm sorry. I held you up. 49 and 5. 49 times 5 is 245. It's been a long day. I'm sorry. 49 times 5. Okay, and then x squared. I thought that one worked. I just... y5 is y4, right? And then there's 1 left over. Okay, so that's going to become 7, skip you, x, half of 2, right? y2, y squared. Boy, they're all mad at me because I held them up for like 4 minutes on that one, 245. 5y on the inside, and there's your answer. Okay, Mr. Purdy, 245 is 49 and 5. Know that, know that, know that. Okay, that's it. So if you missed this class, hopefully these notes helped you. Feel free to ask any questions that you need to. Please, please, please. These radicals are huge on the SOL, and it's something that we really need to know. And we will have a quiz, a big quiz on these radicals coming up soon. Okay, I hope this helped you, and I hope